Hey there guys, welcome to the 4.4 lesson, Patterns for Factoring, Day 2. So we've covered some of the patterns for factoring last time. We did difference of squares, some of difference of cubes, and we also did quartic factoring. So now what we're going to do is we're going to focus on greatest common factor and greatest common factoring, or factor by grouping, which is something you've had experience with before. Now greatest common factor, you should have already seen it when you did factor by grouping in the 4.2 lesson. We find the greatest common factor when it's the largest term that can divide evenly, so no decimals, only whole numbers, into a polynomial. It could be a constant, a variable, or both. So sometimes when you would find your GCFs were just 5, or sometimes they were a 5x, or sometimes they were just an x by themselves. So to find your numerical GCF, you have to ask yourself, what number can I divide each number in this expression by? And then when you look for a variable GCF, you ask yourself, does this term in this expression share the same variables? So let's look at our examples. We have example A. So first to find my numerical GCF, so I'm going to just write here that I'm going to find my GCFs. What number will divide into 12, 14, 2, and 8? The easiest way to do is look for your smallest number and say, okay, what's the greatest number that'll divide into this? And I would say 2. Can I do 8 divided by 2? Yeah. 14 divided by 2? Yes. 12 divided by 2? Yes. So my numerical GCF is going to be 2. And then you look at your variable GCF. So you say, okay, do they all have A's and B's? A's and B? Yes. A's and B's? Yes. A's and B's? No. This one only has an A. A's and B's? Yes. So since they all do not have an A and B, I go back and say, okay, well, they all have A's, A. Then I can see, okay, do they have more than one A? Well, the smallest exponent this one has is 1, so I can only take one A away from it. So my GCF is 2A. So I'm going to put that, similar to factor by grouping, in front of my parentheses. And then I'm going to say, okay, well, 2A times what is 2AB? Well, I know that 2A times 6, or 2 times 6 will give me 12. I already have my A, so I don't need another A, but I don't have a B. So 2A times 6B is 12AB. Then you say, okay, well, 2A times what will give me the 14A squared B? So I'll start with my numbers. 2 times what is 14? Positive 14, so positive 7. I do already have my A, but this time I need an A squared. And I know A times A is A squared, so I do need an A here. And I need my B. Now onto my third term, 2A times what is positive 2A squared. Now you can say 1, 2 times 1 is 2, but 1s are usually implied ones. So unless it's the only thing, I won't write 1. I have my A already, but I need an A squared, so I do need another A. And then 2A times what is negative 8AB squared. So 2 times what is negative 8? Well, 2 times negative 4. I already have my A, and it's not an A squared, so I don't need another A. But I do need a B squared. And this is your answer. So for this first part, you're just pulling out the GCFs and not going any further than that. Well, I say that. For now, we're just pulling out the GCFs. So then we go on to example B. And remember, if your leading coefficient, if your first term is negative, you have to pull out a negative for your GCF. So no matter what, I know my GCF is negative. Then I look at, okay, what's the smallest or the greatest number that'll divide into all of them? So I look at my smallest number. Okay, 4, let's try it. Can 4 divide into 12? Yes. Can 4 divide into 28? Yes. So my numerical GCF is negative 4. They all have the same variable, so it's going to be u, definitely, because they all have u's. But this one has u to the 4th power, u to the 3rd power, u to the 2nd power, which means I can pull out 2 u's from each. I can pull 2 from here, 2 from here, 2 from here, and they'll still have leftovers. Whereas here, since this one only had 1, I cannot pull 2 a's away from here. So negative 4u squared is my GCF. So let's go term by term. Negative 4 times what is negative 12? Well, negative 4 times 3. And then I already have my u, but I need u to the 4th power. So I need a u squared. U squared times u squared is u to the 4th power. So remember your exponent rules. When you're multiplying exponents with the same base, you add your exponents. Another way you can think of it is this u to the 4th power is u times u times u times u. This one's u times u times u to the 3rd power, and this one's u times u. Since I'm pulling out 2 of them, that means 2 got pulled out, 2 got pulled out, 2 got pulled out. So you can see that, hey, this one has 2 u's left over. That's another way to think of it. So then I'll go into my next one. Negative 4 times what is negative 28? Well, negative 4 times positive 7 will give me negative 28. And then u squared times u will give me u to the 3rd power. Or I'll see that once I took out my GCF of 2, I still had 1 u left over. And then finally, negative 4 times what is negative 4? Well, negative 4 times 1, positive 1. And 1s are usually implied ones unless there's something else. So let's see if there's something else. I already have my u squared, and you can see here that there's no leftover. I pulled out all the u's I had. So this time I actually will write the 1 because it's not an implied one. If you don't put a 1, it's 0. Whereas here, if I don't put a 1, it's just a. So hopefully that made sense. So this one's my answer for B. And once again, you're just getting it to its simplest form. Now, something you should be checking, and we'll check in example C and D, when you have something in the u squared, u, and then just constant in your quadratic form, you should be checking to see if you can factor it. Now, this one can't factor, and that's because if I try to factor it, I would multiply 3 times 1, which is 3. So I need to multiply to 3, but add to 7, which is impossible. So this one's not factorable because nothing multiplies to 3 and adds to 7. But that's not to say that all of them will be non-factorable. Some of them may be factorable. So hopefully you're getting the hang of it. So we're going to do the next one. So I have my GCF this time, and I'm going to see the numerical GCF first. So I look at my smallest number, which in this case is 2. 2 will not go into 5, and 2 does not go into 5. Or 9. So don't always assume your smallest number is your GCF. In this case, I don't have a numerical GCF. The smallest number that will go into all of them is 1. 1 will divide into 5, 1 will divide into 9, and 1 will divide into 2. And then they all have Q's. So I'll definitely have a Q. And then to see what's the largest Q I will take out of them, you could do what we did before, which is Q times Q times Q, Q times Q, and then just a Q. I can take 1 from here, 1 from here, 1 from here. I cannot take any more from here because it doesn't have any more to take. So it's just 1 Q. Or just Q on its own with an implied 1. So Q times what is 5Q to the 3rd power? Well, I need a 5, and I definitely need a Q. And I can see here that I have 2 Q's left over, so 5Q squared. And then I need a positive 9, because Q times 9 is 9Q. And then I can see that when I took a single Q out, I still have a Q left over, which makes sense because Q times Q will give me the Q squared. I need the minus 2. And actually here, when I do my minus 2, I can see that, hey, there was no more Q's left over, which makes sense because Q times negative 2 is negative 2Q. So I don't need another Q here. Now, you would say this is your answer, but we're not going to stop here because we have to check, okay, can I factor this? So you would say, okay, well, Then we multiply my first and last term, which is negative 10. And then I need to add to be the middle term. So can I find two numbers that multiply to be negative 10 but add to be 9? And in this case, this one is factorable. So you must factor it. So I'm going to factor it here on the side. So I'm going to rewrite my problem, starting at the 5q squared, and I'm going to separate my 9q into a 10q minus 1q. Because 10q minus 1q is 9q, and 10q, or 10 times 1, is 10, which is what we needed here. Or 10 times negative 1 is negative 10. And then I will bring down my minus 2. So this is just the factoring by grouping we did in 4.2. And then remember, we put parentheses around the first two terms, and similar to what we're doing right now, we have to find the greatest common factor. So in that case, it is 5, because 5 goes into both 5 and 10. They both have q's, so 5q. 5q times q is 5q squared, and 5q times 2 is 10q. Then the greatest common factor of my last two terms, since my first term is negative, I must pull out a negative. And then the smallest number that goes into 1 and 2 is just 1. So negative 1 times q is negative 1q, and negative 1 times 2 is negative 2. I know I've done it correctly because my two parentheses are the same. So that's going to give me q plus 2 and 5q minus 1. And then remember, since my two parentheses were the same, that's where this came from. And then the numbers that are outside the parentheses, oops, I highlighted the wrong thing. Can I go over that? Good enough. These were the parentheses that were the same. There we go. So I'm going to rewrite my problem. I'm going to keep the q from here. So I still had a greatest common factor q, but then I had my q plus 2, which came from here, the parentheses that were the same, and then my 5q minus 1, which came from my greatest common factors there. You would check for difference of squares if these were squared, but they're not, so this is my answer. So be careful and make sure to check if they're factorable, because then you'll have to continue your problem. So we're going to do example D. So for example D, leading coefficient is negative, so my GCF has to be negative. Smallest number that goes into all of them, or the greatest number that will go into all of them. Look at my smallest number, 3. 3 goes into 3, 3 goes into 6, and 3 goes into 45, so negative 3. Then I can look at my x's. X to the 4th power is x times x times x times x. X times x times x, which is x cubed, and then x and x. So I can see that I can pull a single x from all of them and still have leftover in all of them, a second x from all of them, but notice now this one has no more leftover, so the most I can pull out is x squared, and x times x is all I can pull out from all three terms. So that's my GCF, negative 3x squared. So negative 3x squared. And then work backwards. Negative 3 times 1 is negative 3, so it's already negative 3. And then I can see I have two leftover x's, so x squared, or x squared times x squared is x to the 4th power. Negative 3 times what is negative 6? Well, negative 3 times 2. Negative 3 times what is positive 40. Oh, whoops, my bad. Positive 2, and I have a single x left over. And then you go to the next one. Negative 3 times what is positive 45? Well, negative and negative will make positive, so it has to be negative. and 15. Negative 3 times negative 15 is positive 45, and I already have the x squared, which you can see here. There's no more leftovers. Then I have to check, okay, is this factorable? So I need to multiply to be 15, but add to be 1. Well, my factors of 15, and I can put them down here in the corner, are 1 and 15, 3 and 5. Can I get either of these to add or subtract to be 2? Well, yes, the 3 and the 5. So I'm going to rewrite my problem right here in the corner. X squared plus 2x minus 15, and hopefully you're writing small because of this. And since I want a negative 15, one of them has to be positive, one of them has to be negative. And since I want a positive 2, it has to be a negative 3. Negative 3 times 5 is negative 15. Negative 3 plus 5 is positive 2. So I'm going to change this to a negative 3x plus 5x, and then bring the rest of my problem down. So the minus 15 and the x squared. I'm going to draw parentheses around the first two terms. Now, x squared has an implied 1, so the smallest number that will go into 1 and 3 is 1. So a 1x, because they both have x's. X times x is x squared. X times negative 3 is negative 3x. Do the same thing here. First number is positive, so I can just pull out a positive GCF. Smallest number that goes into 5 and 15 is 5. They both do not have x's, so just 5. And then 5 times x is 5x, and 5 times negative 3 is negative 15. Lucky me. These two parentheses are the same. So x minus 3. And then my other parentheses will be the GCF, so the numbers in front of those parentheses. So the x plus 5. Which is really nice. So I'm going to rewrite my problem, keeping the negative 3x squared. I'm then going to write my x minus 3 and my x plus 5. This is where the x plus 5 came from. And then the x minus 3. So this entire thing became this down here after we factored. And this is my answer. So not bad so far. You just have to double check to see if you can factor, and if you can factor, factor your problem. If it's in quadratic form, which is just x squared, x, and then constant. X squared, or variable, I say x. Q squared, q, and constant. So if it's in that format, you should check to see if it's factor. Now, they don't always factor. Remember, this one didn't factor, because it would be multiplies to 3 but adds to 7, which is impossible. But if they do factor, you must factor it. Whoop. So let's go on to the next part of our notes, which is factor by grouping. This one's a little bit easier because this one's just what we did last time. And now we do factor by grouping. You do have to start by checking to see if there is a GCF. So smallest number that divides into all of them. My smallest number is 2, but 2 will not divide into all of them. 2 does not divide into 3. So it's really 1. And then they all do not have the same variable. We have x cubed, x squared, x, and then no x. So there's actually no GCF, or the GCF is 1, which will not change the problem. So I'll just do it like normal, which is to say I'm going to draw parentheses around my first two terms. And you'll say, okay, what's the GCF of just the 2 and the 8 now? Because I'm only looking at what's in the parentheses. Well, it's a 2. And they both have an x. I can pull out an x squared from both of them. So then from here, you say, okay, well, 2x times what is 2x cubed? Well, I need another x. And then 2x times what is 8x cubed? Well, I already have the x cubed. I just need to make it an 8. So times 4. And you'll do the same thing here. Greatest common factor is 3, because 3 will divide into 3 and 12. They both don't have an x, so just 3. And then 3 times x is 3x, and 3 times 4 is 12. Similar to before, when we're doing factor by grouping, your parentheses just still match, even if they're not x squared problems. Which in this case it does, so that's part of my answer, x plus 4, great. The other part of your answer is similar to when you were doing factor by grouping with regular problems. Should be the numbers outside. So 2x squared plus 3. So that's why we learn factor by grouping, because it works not just with x squares, but also for higher degree polynomials. Now, you should be checking to see if you have a difference of 2 squares. So anytime you see an answer that has an x squared, they're not subtracting, so it's not a difference. So this is my answer. So then we're going to do example B. Same idea. First, you have to check to see if there is a GCF. So I'm going to look at my smallest number 2. 2 goes into 2, 2 goes into 10, 2 goes into 70, and 2 goes into 14. So in this case, I can pull out a 2. Now this one has H, this one has H, this one has H, but this one does not have H. So my GCF is only 2. So before I start my problem, I need to pull out that 2. Which will make this a 5h cubed minus a h squared minus a 35h plus 7. Because 2 times 5 is 10, 2 times negative h is negative 2h squared, 2 times negative 35h is negative 70h, and 2 times 7 is 14. Once you pull that GCF, then you can do factor by grouping. So I'm going to group my first 2. So I'm going to keep the 2 out here. Greatest common factor of 5 and 1 is just 1. They both have h's though. And they both have at least h squared. So there's 2 h's I can take away from at least both of them. So that's going to be with 5h minus 1. Because h squared times 5h is 5h cubed. H squared times negative 1 is negative h squared. Do the same thing for the next 2. Since my first term is negative, I do have to pull out a negative GCF. And then the largest number that goes into 35 and 7 is 7. They both don't have h's, so it's just 7. Negative 7 times 5 is negative 35, and then you need the h for the negative 35h. Negative 7 times negative 1 is positive 7. And then you'll notice, hey, lucky us, I say lucky, nice, that our parentheses still match 5h minus 1, 5h minus 1. So I'm going to keep my 2 from the outside, and then I'll have my 5h minus 1. And then my other parentheses, remember, oh, oops, h squared minus 7 comes from what's left out outside those parentheses. That's it. That's your answer. Now you should be checking, like I said, difference of squares. So I do see that something's squared, but 7 is not a perfect square, so I cannot separate it into a difference of 2 squares. So that's my answer. So now we're going to go to example C and D. So for example C, what we're going to do is we're going to say, okay, well, I need to find my GCF first, if there is one. So I'm going to look at the smallest number, which is 2. So we'll divide into 16, but 2 will not divide into 5. So this one does not have a numerical GCF, and they all do not have the same variable. So they all don't have a GCF, so I'm going to go straight to drawing my parentheses. The greatest common factor of 40 and 5 is just 5. And they both have at least a g squared. So 5 times 8 is 40, and then I can multiply it by a g to get g cubed. And then 5 times negative 1 will give me negative 5g squared. So 5g squared times negative 1 is negative 5g squared. Going on to the next part, First term is negative, so I know my GCF has to be negative, or at least the first term in the parentheses. 2 and 16 has a greatest common factor of 2. Negative 2 times 8 is negative 16, and you need that G. Negative 2 times negative 1 is positive 2. And lucky us, it turned out great. So it's very nice that factor by grouping has kind of that built-in self-checker. And then remember, our answer are the greatest common factors in the front. 5g squared minus 2. Ta-da! I mean, you would check for difference of two squares. I do have something squared, and they are being subtracted, which is the difference. 2 is not a perfect square. There's no way I can multiply the same number by itself to get 2, because 1 times 1 is 1, and 2 times 2 is 4. So my answer will stay like this. Do the same thing here. We're going to look for my GCF. So I'm looking at my smallest number, 12. 12 goes into 12, 12 goes into 12, 12 does not go into 20, but you should notice that they're all even. So they can all be divided by 2, but that's not your greatest common factor. They do have a common factor of 2, but there's a bigger one. What number will divide into 12 and 20? So hopefully you're able to see that it's 4. I can divide 12 by 4 to get 3, and 20 by 4 to get 5. And then, in this case, they all do actually have D's. So I can pull out the common variable. So, before I start drawing my parentheses, I need to factor out the 4D. So 4D times 3D cubed is going to give you 12D to the 4th power. 4D times 3D squared is going to give you 4D cubed. 4D times negative 5D will give you negative 20D, and 4D times negative 5 will give you negative 20. Now that you pulled out the GCF, now you can draw your parentheses. So, we're going to leave the 4D here for now and ignore it. Greatest common factor of 3 and 3 is just 3, and I can pull up to a D squared from both of them. So 3D squared times D is 3D cubed, and 3D squared times 1 is 3D squared. First number is negative, so my GCF should be negative. The greatest common factor of 5 and 5 is just 5. Then 5 times D is negative 5D, and 5 times 1 is negative 5. Numbers inside the parentheses are the same. Then I'm going to take the numbers that were outside the parentheses. So your 3D squared and your minus 5. And then do not forget to bring down the greatest common factor from the beginning. I see something squared, it's being subtracted, but 5 is not a perfect square. So, that's your answer. From here on out, that is the end of your notes. So mostly you're just working with greatest common factors and working with polynomials to higher degrees. So make sure you know things like d squared times 3 is d cubed, or that d times d is d squared. And just be careful with your exponents. That I assume is what most students will struggle with. Otherwise, if you have questions, feel free to ask your teacher, come to tutoring, and have a nice day.